Hi, it's Mr. Mac, and in this ninth in our series on math skills you need, we're going to look at areas of circles which we've seen before, but also looking at areas of sectors and composite shapes.
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's Physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
Here's a very delicious looking sponge cake for someone's 21st, someone in our family, and you can see a diagram on the right hand side of sectors of a circle, and that's what we're going to be focusing on today. My preference is not for sponge cake with jam and cream, but carrot cake with walnuts in it and lemon icing on top. We're learning to calculate areas of circles, sectors and composite shapes, and we'll be able to use formulae to evaluate areas of circles, areas of sectors and composite shapes. A circle, as we know, is a round plane figure with a circumference consisting of points equidistant from the centre. And so here's a diagram of a circle with a diameter going straight through to the centre and a radius of 3 metres. The area of a circle, as we've seen in the past, is pi r squared. In this case, pi times 3 squared, which on the calculator turns out to be 28.274, and the digits keep going, metres squared, which will round to 3 significant figures as 28.3 metres squared. An annulus is a plane figure consisting of the area between a pair of concentric circles. You can see in the diagram that the outer circle is red and the inner circle is white, and the radius of the outer circle is 8 centimetres, the radius of the inner circle is 5 centimetres, and we want to find the area of that red part. Well, the area of an annulus, we can just say, well, it's pi r squared minus pi r squared, where the first one is the area of the large circle and the second one is the area of the small circle. But you'll notice we can factorise that and take pi out as a common factor. And when we do that, we end up with pi times brackets big R squared minus small r squared. So the area of an annulus, we're going to use this formula, and in this case we're substituting 8 for big R and 5 for little r. And when we do the calculation, it's 122.522 centimetres squared, or 123 centimetres squared rounded to 3 significant figures. Now let's have a look at a semicircle and a quadrant. A semicircle is literally half a circle, and a quadrant, there are 4 quadrants in a circle, so it's a quarter of a circle. And I'm going to use the same radius as in the previous question, just for convenience. The area of then a semicircle is a half pi r squared. And so a half times pi times 3 squared is 14.137 centimetres squared, or 14.1 centimetres squared, correct to 3 significant figures. For the quadrant, it'll be a quarter of the area of a circle. So a quarter times pi times 3 squared, which is 7.068 centimetres squared, or 7.07 centimetres squared, correct to 3 significant figures. Now we want to have a look at a sector. A sector is like cutting out a piece of pizza or a piece of cake from a circular cake. So it goes to the centre. In this case, we're going to use a small circle with a radius of 4 centimetres, and the sector has an angle of 40 degrees. Now the area is given by this formula. Theta is that small angle. Theta is a Greek letter that we use often for angles. Theta over 360 degrees gives us the proportion, and that's the fraction of the area. So simply the area of a sector will be theta over 360 degrees times pi r squared. And substituting, the r is 4 in this case, and we find the answer is 5.585 centimetres squared. Make sure you can do that on your calculator without any errors. and that's rounded to 5.59 centimetres squared, correct to 3 significant figures. Now let's have a look at a composite shape. This composite shape is made up of a quadrant, and we've taken away a triangle. It's a right-angled triangle. Now we know how to find the area of both of those, so we can subtract to find this area of this very thin shape, which is a segment of a circle. So the quadrant is a quarter pi r squared, as we saw before, and we're taking away the area of that triangle, which is a half base times height. Substituting, the radius is 6 meters in this case, so we replace r with 6. It's also the base and the height of the right-angled triangle, so substituting 6 for each of those as well. On the calculator, we get 10.274 meters squared, or simply 10.3 meters squared, correct to 3 significant figures. Here's another area of composite shape question, and you can see it's our birthday cake, and some slices have been cut out, as sectors have been cut out of this, and the question is to find the area of the top of the remaining cake formed after a sector of 125 degrees has been cut and removed as shown. So let's have a look at this. We know that the diameter of the cake is 24 centimeters because it's a bought cake with lots of jam, lots of cream. And the radius must be half of the diameter, so it's 12 centimeters. And here's where we do the subtraction. The angle remaining is 360 degrees. That's, of course, for the whole circle. Take away the angle of the sector that's been removed, and that's the 125 degrees, leaving us with 235 degrees. So we use our sector formula, and it doesn't matter if the angle is acute, that's less than 90 degrees, or obtuse, that's between 90 degrees and 180 degrees, or as in this case, a reflex angle which is greater than 180 degrees and less than a full circle. We can still substitute theta for 235 degrees, which we'll do, and the radius, of course, is 12 centimeters. When we substitute, we can calculate that to get 295.309 centimeters squared, or 295 centimeters squared, correct to 3 significant figures. And there's our birthday cake. 295 centimeters squared of the original cake remains to be eaten later on. So we've seen how to find the area of composite shapes, including sectors, including when someone's cut a few pieces of cake away and what's the area of the top that's left. And in our next video, we'll be looking at how to approximate irregular shapes in their areas. I'm Mr. Mac. Thanks for watching.